In this video, I would like to discuss grouped data and how to build or group your data. If you are a researcher, if you're the one who's doing a research, I copied our raw data from the previous worksheet, and I already organized it from smallest to largest. It's easier for us to work with, and any computer software will do this for you. Now, when do we use group data? Let's talk about this first. Well, group data is basically uh, used for mostly for qualitative data. So if I group my data based on, let's say, if I collected information about the highest educational level of parents of all Mesa College students, then I would group my data by um, the education level of a parent. So, for example, those would be high school diploma, or would start with no high school diploma, and then high school diploma, and then vocational certificate, or then associate's degree, bachelor's degree, and so forth. So those would be my groups, my categories. Okay. Now for we have a quantitative data. When would we want to group quantitative data? When we have a large amount of data. So it doesn't make a lot of sense to create groups for the data that we have, because it's very small data set. But let's pretend that it's big and we need to to group it. How would we go about it? So here's, first you have to decide how many groups or classes you're going to have. So depending on the book and the software, it could be called groups, classes, or bins, or maybe something else. I will let you know if I find out. These are the three that come to my mind right now. So classes, bins. I know that StuckCrunch calls them bins, and that's what we're going to be using a lot. So get familiar with that term. Classes, bins, groups. Those are all synonyms. All right. So how do we do that? How do we go about doing that? So here you have to decide how many classes you want. So let's say that for this data set, we want 5 classes. So 5 classes. So I need to figure out what is called a class width. And the way to figure it out, you're going to take your maximum value, subtract your minimum value, and divide by the number of classes that you want. So my maximum value here is 73, and my minimum is 60. So, and the number of classes is 5. So I'm going to do 13 divided by 5. And that gives me 2.6. Now I want my class width for this type of data. This is a discrete data, by the way, right? So I want my class width to be a whole number. So, I mean, it depends. It doesn't have to be a whole number. For example, if you're measuring, rainfall in millimeters or inches or whatever, you could have tens or hundreds of a unit. Okay, so but you have to decide what kind of value you want. So basically, for your class width or bin widths, you're going to have the same type of variable that you collected. Okay, so for example, if you're doing rainfall and you have hundreds of inches, then this would be also in hundreds of inches. Okay, our data here is a whole number, so I want a whole number. And here's another very important thing: you have to round up always. So even if it was 2.2, I would still round it up and get 3. My class width would be 3. If you round down, you will end up with more classes that you want. So if I round it to 2, I would end up with 6 classes instead of 5. So by rounding up, you make sure you don't go over the number of classes that you need. Okay. So let's do this. I have this worksheet that I already pre-made. Okay, so and I'm gonna build my classes. So I'm gonna start with the lowest value that I have, and this is 60, and this is gonna be my lower class limit. So my first class starts with 60, and this is called a lower class limit. And then we're gonna determine where my first class is gonna stop later, and it's gonna be the upper class limit. So to find the lower class limit of the next class, I would add my class width value onto this lower class limit value. So that gives me 63. That's where my next class is gonna start. And for the next class, I'm gonna add 3 again, and that will give me 66 and 69 and 72. Okay, so these are the starting points of each class or each group. Now let's talk about how to figure out the upper class limit. So if my, so the rule is your classes should not overlap. So that if we get a value, we know which class it belongs to. You should not have to choose whether to put it in one class or the other. It has to be clear cut. You have to know which class it belongs to. And so these class descriptions should be unique so they don't overlap. So if my first class starts with 60 and my second class starts with 63, so in order for this class to cover everything up to 63, it has to run to up to 62. So that's going to be my upper class limit for the first class, 62. And it's based on the fact that the next class starts with 63. Okay, so the next class, the third class, starts with 66. So this class should cover everything up to 66. So it's up to 65. So again, because we have a discrete data, we don't have anything between 62 and 63. So this cluster covers everything up to 62. And this class covers everything between 63 and 65, including 63 and 65. So there is nothing left out, no data values left out. That's very important. So between 62 and 63, there is no data because our data is discrete. So we're good. Nothing is left out, and at the same time, nothing overlaps. So we're going to continue this pattern to figure out our upper class limits for the rest of our classes. Now for this one, there is no next class. So we're just going to apply the pattern, the same pattern that we had. So what is the pattern? Well, there is a distance of 3 units here and here and here and, oh, you guys don't see, okay, and here. So same thing here, we have 3 units, 3 units, 3 units. So we're just gonna continue this pattern. So, and where did 3 come from? Well, that's our class width. That's our 3. Okay, so from 71 to 74 is these are 3 units apart. Okay. One thing that I want to point out right here, and sometimes I have this question, I may have this question on a test. I may give you a table, the frequency distribution that's already grouped, and ask you what's the class width that was used here. And sometimes students go, oh, the class runs from 60 to 62, so that's 2. They do 62 minus 60, and it's 2. And this answer is wrong. This is not what you should do, okay? Because really, this class, it covers 60, 61, and 62. So it covers 3 values. So it's actually 3, but that is even incorrect. The incorrect way to figure out the classes, because it's not really how many values it covers, because imagine if we have not a discrete data but continuous data, then we're in trouble, because there's going to be more than just 3 values. So the way you figure out the class width is you take the lower limit of a second class and subtract the lower limit of the previous class. You could do it with either one. You could do lower limit of the third minus lower limit of the second, or the fourth minus the third. It's up to you, but you have to take a lower class limit and subtract the lower class limit of the previous class. You do this, you can do the same with the upper limits, you will get the same result, but it's not in the same class. You have to go vertical. Just think of that. You have to subtract vertically, not across, the numbers across. Okay, so we finished setting up our groups. So that's the process of setting up the groups. Now we have to fill in the frequencies, and that is how many data values fall into each class. I now folded our worksheet so we could see all the data values. So basically in the frequency table column, I'm going to fill out how many values I have between 60 and 62, including the endpoints. So I have 1 and 2. Hold on, did I miss the value? Give me a sec. You know what? I did, and I had another value of 62 in here, so we're going to insert it. So between 60 and 62, I have 3 values. So the frequency of this class is, of this group, is 3. And then between 63 and 65, I don't have any 63s or 64s. I have only 65s, and there's 3 of them. So I'm going to put a frequency of 3. And then between 66, did I put 65 here again? This should be 68. So between 66 and 68, I have a 1, 2, 3, 4, 5. So 5 values in this group. And then from 69 to 71, I have 2 values. And there is 1 value between 62 and 72 and 74. Okay, so this is my frequency distribution. Now, if you add all the frequencies, you should get the sample size. Okay, so if we add, remember the symbol that stands for adding all the frequencies. F stands for the frequency of a class. So frequency, when we add up all the frequencies, you should get the sample size. So in our case, our sample has 14 values. So we have 1, 2, so 3 and 3 is 6, plus 5 is 11, plus 2 is 13, plus 1 is 14. So n is 14. And so the sum of all frequencies is 14. This is how you construct a frequency distribution. And we're gonna talk about the other parts of it in the next video.